So let's go into normalizing the state and the code names. Because we're going to need to join, we want to find one single major data frame with all this information. We have the state, and then there's taxes, and there's population, and there's GDP, and there's poverty, and they're separate. They're not in one data frame, so we need to put them together. There's one here, for example, taxes just has taxes. And poverty is not even on the state level, so we're going to need to think about how to do that as well. So first, we're going to normalize the columns. So we're going to make sure every state name column in all data frames have the same name, because that's how we're going to be able to join them. We need to have the same name. Some of them are called state, some of them are called state name, some of them are called capital S state. So we want to make sure, I suggest you just use state name for the name for all of them. And this is the way we do it. This is one way to do it. This way here, I'm creating a new column in each data frame called state name, and then just copying whatever was in the original one, whatever it was called. Some of them are state with a lower s, some of them are state with a big S. You got to go double check on your, some of you don't even have state name. This doesn't even have state name. This only has postal code, which is a state code. Some are state names, some are state. So when you got to go check for every one and make sure we're going to create a new column. Every one of them is going to be either called state name or state code or both, because eventually we're going to need both to join them. And the other word for join is merge in Python. And then check to see if it changed. So this one, it changed over here. State name for came up. Now, I didn't fix the value. It's still Vermont with an asterisk, and we're going to need to remove that, because that's can create problems too if we need to merge on this word, because the other ones don't have asterisks. And also remember, this one is the one that has an issue with the background with the character encoding, which who knows when that would give problems. Okay, next we're going to talk about cleaning up values with strange characters. Okay, cleaning up values with strange characters. So we're going to need to remove the asterisks from the state GDP. And also you can use regress here if you remember. But this operation is very simple. You actually don't need regress. So what we're going to do is we're going to use the replace function of the string function of the pandas data frame. So of course, we always take it from the right and put it in the left, right? So we always begin here when we have an assignment. So we have state GDP in just the state column, so the original one that has the name. And then .str means we're going to think of this, all the values as string as they are. And then we're going to use this replace function, which it is known as a function because then it can open up to a parentheses that has input. And then what happens is the first thing inside the parentheses is the characters that we want to change. And then the second thing after the comma is inside the parentheses, can be a single quote parentheses. I'm sorry, single quote, not inside, yes, here's inside the quote and here's inside the quote. So asterisk inside the quote, first input, comma, and the thing that we want to change to, which here's nothing. There's not even a space. A space would look like this. It's not even a space. I just want to remove it. So we can do it like this. I have regress true, but I think we don't even need to have regress true in this one, because this is simple. Just look at this character and then change it to nothing. So is going to go through every row of this column and change every instance that has this and just put nothing in its place. And then if you run this, and you can see, oh, state Vermont, and notice that how we're putting it into the state name, the new variable. Let's forget about the old one. We're calling everything state underscore name. And it looks like it removed the asterisks, and it's good. Now there was that that hidden encoding thing, but we can take care of it later. Now another issue was that on one of the data sets, the population data set, let's see if I came up here, I had some extra places, state name, that had these strange characters here, like a square bracket, 10 square bracket. And I thought this might complicate us. So we want to get rid of these square brackets, because other places probably don't have square brackets But of course, these look to be like, okay, this is American Samoa, Guam. These are territories. That's why they have something else different. But anyway, I just want to remove those square brackets. Or if you have any other issue like that, you can do it like this. You can use the replace function. And here I do use regress. And regress, as we will do a review next few weeks, it identifies, it's kind of like code to identify different characters. So what this says is identify any values from 0 to 9, so any numbers from 0 to 9, or a left square bracket or a right square bracket, and remove that and put in its place, put nothing in its place. And I did do that, and then removed, this is the output. Notice how the output, you don't need to put print for the output of the data frame. You just write out the name again. And once this runs, it shows the whole thing, or you can just show the top 5 by using dot head, open and close parentheses. So that's that. We also, here, I wanted to do, there's some other issues I kind of pointed out. So some of the words, some of the state names had this /n, carriage return, new line. And I want to get rid of that to make sure all the names are just perfectly misspelled. So if we need to match on them, we need to pair them. They're just going to need to be exactly all identical, capitalized with a space and so on. So I want to make sure to remove that. And also, I noticed there's one time it was DC, and we need to change it to District of Columbia, because in one data set is DC and another data set is District of Columbia. So we need to make sure they go correct. And this at the end here is the one that is the output correct. Notice how I'm creating a new one instead of just changing the old one. I could just change the old one and rewrite over it like this. But I wanted to do a new one, and then we can remove the old one later. And I'm putting this add code here because I'm going to ask you to add the code yourself. And then also there's a money sign. So there's these numbers, these values with money sign. So if you take a look at it, the way you receive it, these are actually not numbers. And there's the data type of each column is very important. Data type of each column is very important. Write this down as a note. So we need to make sure that the data type of each column is correct. So here is string. So we're not going to be able to do any calculations. So we need to remove these string characters. There might be a way to do it automatically, but I'm doing step by step here. So first, I'm just going to remove the money sign. And we remove the money sign. Well, you can just do it like we did before here with the replace, the string.replace function. So you can write that there. And then you should have, and here I just wrote over it. I didn't do a new line with the corrected one, a new column with the corrected one. I just changed over to the, I just changed it over. I changed it in place. Okay, adjusting data types. So once the importance of data type. So you can check the data type by using the type function, type, open parentheses and close parentheses. If you do that just for a column of a data frame, you're going to always get the series data type. So, but if you want to see the actual value of one of the columns, then you have to do something. For example, you can do it like this, because this you get the first item in the series. 0 is the first item. So if you go run, you don't get the actual value. You get the type, because here I put type. And it's numpy integer. It's because that I already changed the data type to be integer. And if you go like that, you actually get the value. This is how you can get first row, second row of this specific column, and so on. Sometimes it can be string. Well, I thought this was, no, this is also, I thought I had a string one, but anyways, this is how to get the correct data types. Now, the thing is, we had the value here with a comma, 34017 in this column, GDP 2020 in millions. So I thought that I could just force this column to be a data type. Like, this is a way to get a data type, is like this. Change the data type as type, and then you put integer, or string if you want to go to string, integer. Now, you can't just do it like this, If you just do it like this, it's just going to change it sort of, it's not going to fixate in the data frame. So if you wanted to actually make sure it stays there, you have to do it like this. You write the column name on the left, and then on the right side, you put it as data type, and this, the value of this goes all into here. And this should work. However, for some reason, this, maybe because this comma was here and it was string with a comma, this function wasn't working. So I found a way. You go online, you ask other sites on the web, and I came up with a solution using this map function. It's a little complicated, but it's just, I got the code here, and then so I'm applying these locale and atof to convert string values with comma so that they can actually turn into numbers, integers. We don't need to be worried about decimal or float because these are big numbers, except I think when we are doing maybe the poverty percentage might be useful to have decimal there, but here generally population, of course, we don't deal with fractions, and some of these numbers are very big, so we don't really need fractions either. Okay, next we're going to be talking about aggregating counties per state.